बघ ना. कॅमेरा दिसतोय का मुलांना? दिसतो? हॅलो students, last time we have started some basic concept of chemistry. In that, we have completed the how to calculate atomic mass, how to calculate molecular mass. Even we have seen the laws of the chemical combination. In that, we have seen the Gay-Lussac law and the Avogadro law of equal volume. Now, let's do a little revision. See, this law we have studied, that is Gay-Lussac law of gaseous volume. So the example which you have taken, that was our water molecule. So equal in this chemical reaction. So when the gases combine, or they may produce in this chemical reaction, they do so in the simple ratio by the volume. So you can see the ratio is 2:1:2. So this is a simple ratio. Here you are not getting 1.5 or 1.6, 2.8. So we are getting a whole number ratio, simple ratio. This is what is given, explained or stated by the Gay-Lussac. Okay. So simply when you are stating any law, after stating the law, you have to give the example also, students. Then only you will get the full marks for that question. Then the Avogadro law, which we have studied, it is also based on the Gay-Lussac law, but here we have to compare with the number of molecules. So when equal volume of all gases, when they combine at same temperature and pressure, they contain equal number of molecules, which is said by the Avogadro. So Avogadro always give an idea about the number of molecules. That way you can remember. So here, as 2 volume of hydrogen combined with 1 volume of oxygen gives us 2 volume of water. So what Avogadro is saying, 2n molecule equal to 2 molecule, n number of molecule equal to 1 molecule, because the ratio of hydrogen combining with the oxygen is what? 2:1. 2 molecule of hydrogen combines with 1 molecule of oxygen, and we get 2 molecule of water. After that, we have seen atomic mass. So when you want to calculate atomic mass of any element, you have to consider carbon C12 as a reference element, and atomic mass of one atom of carbon 12 is 1.992648 into 10 raised to 23 gram. So when we want to calculate atomic mass of any element, it is represented by the unit 1 AMU. 1 AMU means atomic mass unit. Okay, so from this calculation or from this formula which is given, we can write the definition that 1 AMU is defined as 1/12 mass of 1 C12 atom. Okay, mass of 112 C12 atom. Isotope of carbon was, which is used, is C12, and mass of that one atom of carbon is this, which is already calculated from the mass spectroscopy. And when we will divide this 1.992648 by the 12, what we get is 1.66056 into 10 raised to minus 24. So 1 AMU is always equal to this value. And on the base of that, one problem is in the book. So that problem, if you have book right now open, on page number 7, you can see mass of oxygen is given, and you have to calculate atomic mass of oxygen. Mass is given, so how you will calculate atomic mass? Simply, you will divide the atomic mass of oxygen by the 1 AMU, and that 1 AMU is 166. So this value we will use to divide mass of oxygen which is given, and on dividing, what we will get is a 16, because atomic mass of oxygen, what, student? It is 16, and that's why we will get answer 16. So 1 AMU, when you calculate, no, in exam if the problem is there, though the values are in fractions, but no need to get confused. You know approximate atomic masses of elements. Suppose you asked to calculate atomic mass of hydrogen, you know it is 1, so your answer should come near to 1. Or for nitrogen, it is said it should come near to 14, that way. Now, average atomic mass. This average atomic mass, This is just the average, because we know most of the element exists in the nature in the different isotopic forms. Now, the example carbon is given here, which is exists in the 3 isotopic form. So these are their unit masses and the relative abundance. The formula we have discussed last time. We have to just take atomic mass of each isotope of element. Here carbon we have used. So first we have taken of C12, we have multiplied with the relative abundance. It is in percentage, so we have divided by 100. Same way of 13C, its atomic mass, we will multiply it with the relative abundance 1.108, and then the third, that is 14.00317, you have to just multiply it with 2 into 10 raised to minus 10 divided by 100. So with this student, average atomic mass is again an easy to calculate. So for whom we will calculate average atomic mass? For the elements which exist in more than one isotopic form. So in the book, the list of elements given, that is nitrogen exists in N14, N15. The oxygen is exist O16 and O17. Hydrogen is also exist in the 3 form H1, H2 and H3. Isotope means what, student? Their atomic numbers are same, but their mass numbers are different. Now let's see the next slide. This is, we are just doing the revision. Molecular mass. Molecular mass, if you'll see, molecular mass is from the word molecule. So whatever will be the molecule, when you will add all the atomic masses of that molecule with the number of atoms. For example, if I want to calculate atomic mass of H2SO4, so number of hydrogens are 2. That's why 2 into 1 U. Why U? Because atomic mass is expressed in the unit U, that is unified mass. Then sulfur. Sulfur is, they have taken 32. Atomic mass of sulfur is 32. And number of oxygens are 16. That's why 16 into 4. So when we will calculate all this, we will get 98. So here you will not write gram. For molecular mass, for atomic mass, you have to always write U. U means unified. Formula mass. Formula mass, if in the exam question is there, define formula mass. So you have to just write that formula mass of a substance is a sum of total number of atomic masses which are present in the given formula. Suppose your formula is NaCl. So how many atoms are present? 2 atoms. One sodium, other one is chlorine. So we will then add their average atomic masses. Now for sodium, average atomic mass is 23. And for chlorine, it is 35.5. So these values, students, we will give. Don't worry in the exam. So accordingly, you will solve the paper. Formula mass of cupric nitrate. Here, again, we have to consider 1 copper atom, 2 nitrogen are here, and number of oxygens are actually 3 to the 6. So here 2 is taken in the common. Average atomic mass of nitrogen plus average atomic mass of 3 oxygen. So copper atomic mass, average atomic mass is 63.5, and that of nitrogen is 14, plus number of nitrogens are how many? 1. Number of oxygens are 3. That's why 3 into 16. And then total, if we'll do 187.5 unit. Now this is formula mass, again very easy. Mole. Mole is again a very important concept which we have discussed. So 1 mole. 1 mole means what? Number of particles or different entities like ion, molecule, atoms which are present in 1 mole. So 1 mole of is an amount of substance that contains many entities or particles as there are in 12 gram of carbon. So it is related with the 12 gram of carbon. 12 gram of carbon contains how many number of atoms, molecules? That is equal to 1 mole. So the calculation again easy here. We have to, here we want two information. What first we want? We want a mass of 1 mole of carbon atom is considered as a 12 gram. Okay, so 1 mole is equal to 12 gram. And we know that mass of 1 atom of carbon is 1.992648 into 10 raised to minus 23. So simply we will divide 1 mole of carbon atom, that is 12 gram, by weight of 1 atom of a carbon, that is 1.99. So we have got 6.022137 into 10 raised to 23 atom per mole. So this is what is Avogadro number. Like as we says, 1 dozen is equal to 12. 1 gross is equal to 144 of the objects. Same way, 1 mole of any element it is hydrogen, nitrogen, chlorine, is always equal to 6.0221367. Keep it in mind. So it's a standard unit which is given. Molar mass is what? It is again very easy. It is a mass of 1 mole of a substance, 1 mole of a carbon. So its molar mass where we will represent in gram per mole. So see, table is given here. Hydrogen, carbon and oxygen. Atomic mass we knows. So, and molar mass, you have to just remove U and you have to write gram per mole. So molar mass, when you are finding out, unit will be gram per mole on inverse. And when you are writing atomic mass, unit will be U. Same way, these are the monoatomic. So polyatomic are there like oxygen O2. So 2 molecule of oxygen means 32. 1 molecule of oxygen means 16. 2 molecule means 32. So you have to just replace U by gram mole inverse. Water 18U will replace by 18 gram mole inverse that way. Understood, students? Now let's go for the problem based on this. So our problems we have not completed. So let's solve problem based on this. Problems are again very interesting. Now see, if textbook is with you, you try to read the problem first. Calculate the number of moles of and molecules. We have to two things we have to calculate. We have to calculate moles as well as the number of molecule present in 5.6 gram of urea. So weight of urea is given. How much it is? 5.6 gram of urea. We want to calculate moles. So what is formula to calculate moles? In order to calculate moles, for mole, you write it down. In order to calculate moles, we require mass of a substance divided by its molar mass. So here substance is urea. Okay. So mass of urea is given. It is how much? 5.6 gram mass of urea. But molar mass of urea we know, molecular mass we know, molar mass of urea we don't know. So we have to calculate it. So for calculating molar mass, we should know the formula. See, formula is not given in the problem. So this formula you have to remember. The formula is again very easy. NH2, C double bond O, NH2. This CO means carbonyl carbon. This carbon is carbonyl carbon. So NH2, CO, NH2. Now, if you will calculate together, how many nitrogens are there? This one nitrogen and this is another nitrogen. So 2 nitrogen. Number of hydrogens are 2 plus 2, 4 hydrogen, 1 carbon and 1 oxygen. So simply we have to calculate molecular mass. So what is molecular mass, student? It is a total of average atomic masses of atom present in the given molecular formula. So formula is NH2CO NH2. So let's try and solve this. So let's first take nitrogen. Number of nitrogens are 2. That's why 2 into average atomic mass of nitrogen plus number of hydrogens are 4. That's why 4 into average atomic mass of hydrogen plus number of carbon is 1. So 1 into average atomic mass of carbon. And lastly, number of nitrogen is just oxygen is 1. That's why 1 into average atomic mass of oxygen. So see, student, what we have learned just now, those formulae only we have used, and the formulae are really easy. No need to mug up them. You have to just understand. You have to practice them. You should write. So you may find it is very easy. No need to write. But if you will not write it directly in the exam, you will try. No, then you will do mistake there. So try writing all the formulas. So you will be surely solve the problem very easily in the paper. Now 2 into average atomic mass of nitrogen, as I have told, 14U plus 1 into what is atomic mass of carbon? It is 12. Then atomic mass of hydrogen is 1. So how many hydrogen? 4. 4 into 1. And 16 is the atomic mass of oxygen. And number of oxygens are 1. So all when we will solve, we will get 60U. We will get 60U. Now this is a molecular mass. And molecular mass we always write in U, unified mass. So in order to, we want a molar mass. So molar mass, how will convert? We have to just write gram mole inverse. Only this difference. These are the very small things which are again important. Gram mole inverse. Now our first finding is what? Number of moles. So number of moles, what is the formula? Mass of urea in gram divided by molar mass of urea. Mass of urea is 5.6 divided by molar mass we have calculated. That is 60 gram. So when we will solve this, here you can use your simple mathematical calculation you can do, or you can go by the log book, log method, you can solve this. So you'll get answer 0.0933 mole. So understood how to calculate mole? So this formula you have to remember, student. Number up now we want to calculate number of molecules. So this also we have done. Number of molecules is what? Number of molecules are the number of moles into Avogadro number, because we have studied just now Avogadro number. Because 1 mole of any substance is equal to number of molecules into the Avogadro number. So we have to just simply multiply number of moles with the Avogadro constant. So 0.0933 into 6.022 into 10 to 23 will do. On calculation this, we will get 5.618 into 10 to 22 molecules. Okay, student, is it clear to you? This is again a very important calculation, very important problem. So both the answer we got, number of moles as well as we got number of molecules of urea. Is there any doubt to you? Shall I repeat this problem again? Anyone please say yes or no, whatever.
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, anyone have any doubt?
No, ma'am.
Yes, who? Shona?
No, ma'am. No doubts.
No doubt, understood?
Yes, ma'am.
So can you tell me formula for finding the number of moles?
Mass upon molar mass.
Mass upon molar
Molar
mass.
mass.
Yeah, and number of molecules when we want to calculate?
Number of moles into Avogadro constant.
Number of?
Moles
Yeah.
into Avogadro's constant.
By that we will calculate the number of molecules. So here it is molecule given. Sometimes we can calculate number of atoms, number of we can electron also we can calculate that way. Okay, fine. Now next problem is again very important. Here 3 different conditions are given. Calculate the number of atoms. See here. Here we are going to calculate number of atoms of each of the following. First is 52 moles of argon. So here argon is given in terms of moles. Okay, one standard condition we know, student. What is that standard condition for each element? 1 mole of any element is equal to your Avogadro number. Now suppose here argon is the our question, argon atom is given. So 1 mole of argon atom is equal to Avogadro number, that is 6.002 into 10 to 23 atom of argon. Now here number of moles are given. So can you calculate the number of atoms? It is just the cross multiplication. For 1 mole, it is 6.022. Then for 52 moles, how much? This is your cross multiplication. So when we will just multiply 52 into 6.022, what we will get is 313.144 into 10 raised to 23 atom of argon. So here we have to just calculate number of atoms. So for that, what the information we required? Number of moles. Now second is what? 52 unit of helium. Unit means it is at what? Atomic mass of helium is given. Okay, 52. What is the standard condition of helium? Atomic mass of one atom of helium is 4 unit, because we know helium atomic number is 2. So its molecular mass, atomic mass is always double. So it is 4 unit. That information is not provided here. Mass of helium, it is 4. So you have to understand that helium atomic number is 2. That's why its atomic mass will be 4. So 52 unit of helium, we have to calculate number of atoms. Now, if one atom is equal to 4, then 52 unit of helium is equal to how many atoms? This is again a simple cross multiplication. If one atom of helium is equal to 4, then 52 unit of helium is equal to how much? So cross multiplication again it is, and by doing cross multiplication, you will get answer, that is 1.3 atom, 13 atom of helium. So 52 we have to just divide by 4. So we will get 13 fours are 52. Understood? Now third condition, see, first was with the moles, second was with the atomic mass, and third one is with the gram. So 52 gram of helium we have to calculate. Now here we have to use little different method of calculation. Here we have to consider our mole concept. So we know 1 mole of helium is equal to 4 gram. Okay, 1 mole of helium. See, 1 mole is always equal to its molecular mass or molar mass is 4 gram. So number of moles of helium, mass of helium, you have to just divide by the mass of 1 mole of helium. On dividing it, we will get number of moles. For 1 mole, it is 4 gram. Then for 52 gram of helium is equal to how many moles? So first we have calculated mole. Okay, here we will first calculate mole. Mole information is not given. In the first problem, in organ, mole has given. Here we will calculate mole. How we will calculate mole? By the standard condition, mass of 1 helium is equal to 4. Then 52 gram of helium is equal to how many moles? So it comes 13 mole. Now you know the moles. So when you know the moles, you can calculate number of atom of helium. So to just multiply with the Avogadro number. See, number of moles of helium into 6.022 into 10 raised to 23. So it is 78.286 into 10 raised to 23 atom of helium. Student, these are the just problems which are given in the book solved. You have to solve problems under the textbook, even these also. So definitely on this chapter, problems will be there in the exam because all formulas we are studying in this chapter. Okay. Now one more, moles and gases. Again, a next important concept, moles and gases. Now how you relate gases with the moles. Okay. So see, this is again very interesting. Keep it in mind, understand it. And if you have any doubt, you please ask me. 1 mole of any gas, okay, 1 mole of any gas occupies a volume of standard volume. What is volume of gas at standard temperature pressure? Anyone can tell me? Yes? Priya, you can tell me? Sakharkar Priya? Volume of gas at HTP, how much it is? It is 22.4 dm cube. Okay, 1 mole of any gas at standard temperature condition always occupies 22.4 dm cube of its volume. Okay, standard temperature pressure condition means what? 0 degree centigrade or at 1 Kelvin or no, at 273 Kelvin or at pressure 1 atmosphere. Now, formulas. Let's see the formulas. So volume of 22.4 dm cube at HTP is known as a molar volume. So if question will be there, what is the value of molar volume at HTP? So it is 22.4 dm cube. Now how you will calculate with the knowledge of this volume of gas, number of moles. So number of moles is equal to volume of a gas at HTP, that is 22.4, divided by molar volume of a volume of gas at HTP, that is 22.4, divided by its molar volume. Okay, so number of mole of gas. Now number of moles of gas and want to calculate volume will be given to you. And we know molar volume. What is molar volume? 22.4 dm cube. From that, from the given information of volume of gas, you can calculate molar number of moles. Only one information you should know, volume of a gas. Then you will simply divide it by 22.4 and you will get number of moles. Now let's see, we will solve the further problem based on this. Now very first problem, calculate the number of moles and molecules of ammonia gas. See, now this is a gaseous substance. Earlier we have used, that was the solid urea. So their molar mass and everything we have calculated. Now here for gas ammonia, what is given to us? Volume of that gas at HTP 67.2 dm cube. So this volume we have written in the data. Molar volume we know 22.4. So just we have to put in the formula. Number of moles is equal to volume of a gas at HTP, that is 67.2, divided by molar volume 22.4 dm cube. On calculation of this, we will get 3 mole. And simply when you know the moles, you can calculate the molecules. You have to just multiply with the Avogadro number. So number of moles, we will multiply 3 with the 6.022 into 10 raised to 23. We will get answer approximately 18.066 into 10 raised to 23 molecules. So easy for gaseous substance and for solid substance to calculate. No problem? Okay. Now with this, we have completed this first chapter. Now students, keep it in mind, in from this chapter, what is there and what is not there. See now, what is there, I'll just tell once again. If you want to note down, you note it down. I have already shared the PDF. 1.3 is there, 1.3, 1.3.1 is there, 1.3.2 is there. After 1.3.2, in the law, Gay-Lussac law, 1.4.4 is there. Then 1.4.5 is there. After that, directly 1.6. In that 1.6.1 atomic mass, 1.6.2 average atomic mass, 1.6.3 molecular mass, then formula mass, then your mole, molar mass, till end everything is there. Okay. Now next, introduction to the analytical chemistry. Just see, we will just do the introduction of this chapter. Again, very interesting chapter. Analytical chemistry. When we have seen the 5 different branches of chemistry, analytical is one of the very important branch. So how, what the analytical chemistry helps us? It helps us, it facilitates different types of investigation where the chemical composition of the compounds, you can see the plant extract, what are the pigments are present in the given plant extract, or fertilizers or pesticides which we synthesize, what kind of percentage of nitrogen, sulfur. So here we can do qualitative as well as quantitatively. We can find amount or volume of any of the component. We can study them. Even in the atmosphere, when we want to calculate the pollution, we want to calculate the amount of oxygen level, amount of level of poisonous gases like carbon monoxide, CO2, SO2. So here analytical chemistry plays a very, very vital role. Now, when we want to see in that, it is of a two type analytical chemistry, qualitative and quantitative. So what is qualitative? Qualitative is you have to do the test, you have to perform the test, where you have to do certain tests where PPT will form, precipitation will be there. You have to extract certain products and you have to do its investigation. You have to find out its melting point, boiling point, to check the purity, if it is solid, liquid, accordingly. Then distillation, if it is liquid component, and if it is a mixture of 2 to 3 component, then we have to separate them with the help of fractional distillation, each and every component based on its melting and boiling point. With the help of color, odor, with the aroma, you can identify the type of compound. So it all comes under the qualitative technique. Whereas next is the quantitative. In quantitative, the name itself, quantitatively we will measure the amount of product which is formed in gram, we will measure. Amount of any gas is extracted in the liquid. So we may measure in terms of volume, dm cube, cm cube, or liquid reactant which is got converted in certain desired color. So at what reading it gives a color change, that is titration experiment, where quantitative plays a very vital role. Even you can with the help of gravimetric technique. Gravimetric is also a technique where solid substance we have to incinerate in a crucible, and we have to find out the type of product result at the end, the quantity, its percentage of yield of that product by the gravimetric analysis experiment. Now let's start with the chemical method of qualitative analysis. First method. Now here in the qualitative analysis, it is of a two types or two stages are there, not two types, two stages, which you will do in the lab. Now when our practical will start, all were asking yesterday on the group, ma'am, what to do in the experiment? We don't know anything. You don't worry about it. As for the first time you are coming to the lab, you come with at least your book with you. We will explain you everything about the experiments in the lab. We will explain what are the experiments are there. So much of questioning was there on the group yesterday. Why you are so confused? You got your batches, you got your timetables. It is clearly mentioned that from 8 your practical are starting, but you refer to your batch, you refer to your timing, and you refer to your day. Still students, you are asking so many questions, and try to ask in the office time, students. Okay, So that you have to understand first. And don't worry, if you're not understanding anything, come when you will come to the college, we are there. We are going to help you only. No need to get hesitate, or no need to get afraid what to do and how to do experiments. We will definitely explain you. You don't know the experiments, we knows. According to syllabus, we will conduct the experiment and you will perform. Okay. Chemical analysis, when you do in the qualitative, we will do it through the two stage: dry analysis, and that is the dry method, and the wet method. Now what is this dry method and wet method? In dry method, whatever sample is given, in dry stage we will do its testing. We will analyze its composition. Okay, we will do certain chemical test for the dry test, so by using the dry sample. But when we come to the wet method, in wet method we have to dissolve that sample into the water. Okay, by dissolving that sample into the water or in suitable solvent, then we will carry out certain test. Now this qualitative analysis, nowadays we are doing it through the semi-micro way. When we are doing it through the semi-micro, the apparatus which you will require are the test tube. You will require a crucible, then certain evaporating dish, beakers, test tube holder, spot plates, different apparatus you will require over there. Then the wire gauze for heating purpose. You will require a centrifuge to separate the precipitate which there in the your test tube which form during the testing. We will require a burner, blowpipe. Now, when we will come to the practical this week, we will definitely go through all the apparatus which are there in the lab, and then we will begin our experiment. Now, in qualitative analysis, are of a two types, students. There you can go for the organic analysis and inorganic analysis. Now, inorganic, inorganic analysis, all different types of metals, non-metals, their tests are there. Organic means what? Detection of a carbon, percentage of carbon, hydrogen, oxygen, or other elements like sulfur, nitrogen present in the given sample of the organic or not. That is what is organic type of a compounds. Now, the majority of compound which are composed, there are a relatively small number of elements which are present in there. Now, the important one which you see in the organic, the presence of, like, we will do test for the sulfur, phosphorus, halogen. And suppose an organic compound, for example, it is a alkyl halide. So for alkyl halide, the test which we are going to perform, where we will get test of halogen. So halogen presence shows that the given organic compound contain halogen. So we will do the test of halogen. So we will come to the conclusion that the given substance is halide, alkyl halide. Elementary qualitative analysis is concerned with the detection of presence of this element. We will step by step, we will do certain tests, and we will end to the conclusion that in this given compound, this functional group is present. Functional group like carboxylic group. If you knows all this, if you don't know, don't worry. We will study when you will do the practical. So right now I'm just giving you the example. Alcoholic functional group, phenolic functional group, amino functional group, different functional groups are there. Okay, determination of melting and boiling point. You can determine their melting and boiling point, and you can come to the know the type of compound which is present. The qualitative analysis of a simple inorganic compounds involves detection of conformation of cationic as well as anionic tests are there. So in inorganic, when you do inorganic ions means what? They are made up of cation and anion. For example, let's take an example of ammonium chloride. So ammonia is cationic species, NH4 plus Cl minus charge. It is an anionic species. So we will do detection of cation and anion. So on detection of these two radical, we will come to the conclusion that, okay, in the given inorganic compound, these are the what elements are present, these are the radicals are present, cationic anion, and the given compound is this. So we have to find out the type of compound given to you, and you have to come with the end that the given compound is this, and its chemical formula is this, and you can write its chemical name also that way. Now the second analysis is quantitative analysis. So quantitative analysis of organic compounds involves method like determination of percentage of constituent element. For example, to determine the percentage of nitrogen, to determine the percentage of halogen, to determine the percentage of sulfur, then the concentration of known compound in the given sample. These two methods involves in quantitative analysis of organic compound. One is what? First, to determine their percentage, and second, concentration of the known compound in the given sample. How much concentration is there? Whereas when we do quantitative analysis of inorganic compound, different methods are there, student. Gravimetric, that is decomposition method. Decomposition is like that a certain compound is given to you, okay, it is associated with water molecule. So when we will hit step by step, first water molecule will evaporate. So all water molecule won't evaporate at the same time. As you increase the temperature, first molecule, then second molecule, like that the molecules will evaporate, then substance will start decomposing. If any carbon is there, then it will combine with the oxygen and form carbon dioxide. So these are the different products which result during the gravimetric analysis. The progress of reaction between the two solution till its completion, that is titrometric or volumetric analysis. Now this is again the very interesting, which is compulsory for you in the 11th as well as in 12th. That is volumetric and titrometric analysis, which we will perform when you will come to the lab. Okay, so here I'll give you the example of the experiment which is there for this year. That is to determine the concentration of unknown sample. Suppose we will take strong acid and strong base. Strong acid is NOH and strong acid is HCl. I know the concentration of strong acid HCl, but I don't know the concentration of given NOH. Okay, so how I'll find out the concentration of NOH? I will use a suitable indicator. Then I will bring about the titration, and then I'll come to know at this particular reading, the reaction, that is acid and base, when they combine, it is a neutralization reaction, salt and water will form. So what we will get is salt and water, and after that the color change will be there in the indicator, and that color change will give us the value, volume, and from that volume we will find out the molarity or normality of the unknown solution. So from known we will calculate concentration of unknown. Okay, again very interesting. And that is by volume, by mass, methods are there to calculate. So student, with this, I think this was the last slide I want to explain with you. Still this chapter we have to complete, chapter yet not completed. Here again, if you'll see in this chapter, introduction part is not there. Importance of analytical chemistry is not there. You just cross there. What is not there in the chapter 2. 2.2 analysis is there. Then 2.21 chemical method of qualitative analysis is there. 2.22 chemical method of quantitative analysis is there. 2.3 is not there. Mathematical operation and error, this year it is not there. Then 2.3.2 scientific notation is again not there. Addition subtraction is not there. We will next time study precision and accuracy of measurement. That is again a very important, precision and accuracy. We will understand what is the difference between the two. Then significant figure 2.3.3 is not there in the exam. Rules of deciding the significant figure is not there. Okay, 2.35 calculation with the significant figure is also again not there. Directly 2.4, 2.4.1, then problem based on it, then 2.5, then 2.51 stoichiometric problems. Again, the limiting reagent, concentration of solution, 2.7, 2.72 is a mole fraction, 2.73 is a molarity, 2.74 molality, and use of graph, that is 2.8. All this is there. This is, see, this both the chapters and the further are mostly a problem-based chapters. So we will solve all the problems, we will understand. So today's lecture is over, student. Have you understood all the points? Anyone can respond? Or if anyone not understood, can ask me. Now your practicals are going to start, so anytime you can meet me and you ask me the doubt. Okay, bye students. हे झालं एंड करायचं.